Hi everyone, I'm Sophia Barnes and I'm incredibly excited to show a demo of this AI agent proof of concept I've been working on for a use case in the reinsurance industry. In this demo, you'll see how I incorporated multiple agents with human in the loop for each agent. Brief overview of how this video is going to work. I'm first going to explain the use case and a bit about the reinsurance industry. Then I'll do the demo, the exciting part. And lastly, I'll finish up with explanation of how I implemented the agents and some design tips. And that'll be the video. So before we actually dive into reinsurance and the use case, I want to say a little bit about what it means to trust an AI agent. We all know that if you give an AI agent full tool access and you unleash it into the world, sometimes there can be unexpected consequences. If it's a travel agent, it could book the user 20 flights to Tahiti. And we want to avoid this situation. So that means we want the user to know what the agent is doing and have the ability to intervene at any point with prompting if the agent goes wild. Now to reinsurance. Reinsurance is insurance for insurance companies. So you can think back to the horrendous wildfires that happened in LA last year. Many people lost their homes, and home insurance companies had lots of money to pay in claim payouts for those burned down homes. In these events, in order to not go bankrupt, home insurance companies will try to hedge against this happening. So they will purchase catastrophe insurance in the event that a major catastrophe like a wildfire occurs. And so that's why we have reinsurance. In reinsurance lingo, one very important term you guys should all know is a cedent. A cedent is the LA home insurance company that will purchase catastrophe reinsurance. Now, as a reinsurance provider, your main task is to take the data you get from the cedent, the historical losses, their portfolio, and ingest it all in order to create a contract and price the appropriate premiums that the cedent should pay for the reinsurance. And a subtask that the underwriters at my partner reinsurance company do that this AI agent is going to help automate is that they will take the submission pack from the cedent. This is typically an Excel file. They will extract the catastrophe loss data from it. These are historical events that happened in the past. So for example, in 2017, Hurricane Sophia rumbled through and caused $450 million in loss payouts that this cedent paid. Or Tropical Storm Gamma in 2018 cost $300 million in loss payouts. Then the underwriter will go and manually link every single catastrophe event to see if there's a matching ID in the historical event database. This is an internal database, so you can execute joins against it. And lastly, they will take that and populate the cedent loss database. So it'll say now 2017 Hurricane Sophia caused $450 million in damage, and it had this ID in the historical event database. Idea behind this process is to take all this data that's hiding in these submission packs. These submission packs all have different formats. They come from different cedents. And to standardize it and put it in this internal database that can then be used for the further processes of figuring out how to write the contract. Okay, so this is the entire process that my AI agent is going to help automate. It's currently done fully manually, which is unfortunate. But let's get into the demo. So this is the UI, and I'm going to start with asking it to process submission pack 1656789. This is a fake submission pack. And so We're going to start at the supervisor agent. The supervisor agent is going to decide that it needs to parse the submission pack. So we are going to confirm the start of the submission pack parser agent. The submission pack parser agent needs to figure out what Excel file 156789 actually refers to. So it's going to find the Excel file on my computer right here. It found it, and now it's going to extract the as of year. This is when the submission pack was last updated, which is needed for the final cedent loss database that we want to populate. So it's going to run this extract as of year tool. Found it, it was in 2023. This was the extracted text that it used. And now it has the Excel workbook, it has the as of year. It wants to figure out where is that catastrophe loss data hiding in this sheet. So we are going to identify which sheets of our Excel workbook actually have the catastrophe information. We're gonna start a sheet identification agent for this purpose. If the underwriter already knew, oh, the catastrophe data is in this sheet, you could have canceled this agent and just written, hey, use this specific sheet, and then it would move on. But we'll actually execute the agent. So these Excel workbooks have many, many, many sheets. And so the first part is going to be to get all the sheet names from the Excel workbook. You'll see this one has 52 sheets, which is a lot. And these sheet names don't really tell the agent much about which one actually contains the catastrophe loss data. So we are going to execute this read sheet tool on the table of contents sheet to see if perhaps the table of contents can give us any clues. And it's reading the table of contents. You'll look at this cat loss summary. Catastrophe loss summary seems pretty useful. Catastrophe loss detail. And based on this, the sheet identification specialist decided that this sheet 2B seems like a good candidate. Now, as an underwriter, I can say, yep, let's continue with it. And this sheet does have the proper data, but I can also ask it to say, can you read sheet 2.c combined to see data? So I'm just asking it to read this specific sheet as well. And so it's going to execute the read sheet tool. I added a full mode and a preview mode. Full mode reads the entire sheet, and preview mode will just read the first 20 rows. I originally had in this argument that it can read as many, it had an argument for the number of rows it wanted to read, and that confused the LLM. So keeping it simple, full mode, preview mode, did a lot useful. This sheet does have catastrophe loss detail data. So actually I'm going to complete it with the 2.c combined sheet. So we're going to use the 2.c combined sheet to actually extract the catastrophe data in the next part. And for this tool, I could just confirm it right away, but I'm going to show how you can add user input when extracting the catastrophe data. I'm going to say extract the catastrophe from 2.c combined. Make sure to use the total gross incurred column for the loss. And so what you can imagine is that this activity, this tool might extract the catastrophe data, but it might not use the correct column, or it might do it incorrectly because these Excel sheets have a lot of information. So you can imagine the user would call it, it would execute incorrectly, and then it would recall the tool with the correct prompting the way the user wants to call it. And so what this does is it appended the user instructions as an argument to the LLM extract catastrophe data tool. Now, to be very clear, the only places where I'm actually calling an LLM in this entire architecture are for the agents. Each agent runs a loop which decides which tool call to call next, using what arguments to those tools, or if it might need more human assistance. So if a tool fails, it might ask the user, hey, this tool failed, what should I do? So that's where the agentic loop is using the LLM. And then the only other place we're using an LLM is in this extract catastrophe data tool to help take the sheet and parse out the relevant loss, like the Hurricane Sophia, 500 million in the year. So we actually just finished the extract catastrophe data tool, and I want to show you how this looks in the back end over here. This is our sheet identification agent that it called get sheet. The agent figured out what tool to call next. We confirmed the tool. We read the sheet. Agent figured out what tool to call next. And then we canceled the completion of the agent. We figured out what tool to call next, read sheet, and then we actually confirmed completion. So this is kind of what's happening on the back end. So this is our submission pack parser agent. We can see that this LLM extract catastrophe data activity tool completed. And now we are going to confirm the completion. The submission pack parser agent, there were 59 different catastrophe events in the sheet. And now for every single one of those events, we're going to match it to the historical DB. And so this is going to start a bunch of parallel workflows to match every single event to see if it has a match. And this is also pretty cool to see on the back end. So yeah, so these are all the historical events. It ran them nearly in parallel to match the events. And here we are. An underwriter should actually go through and make sure that it did it correctly. But for the purposes of this demo, we'll move on to populating the cedent data. So that means taking the output from the historical matcher and the output from the submission pack parser agent to actually create the records for the cedent data table. And so here's an example of what these records should look like. Looks pretty good. And now we'll actually compare it to the existing cedent data. There's usually existing cedent data and a new submission pack for, say, the next year or the next few years will arrive. And so we want to update the existing data, see if there's any new additions or any changes to the old events. So we see that there were 31 new additions identified and 28 unchanged records from the old years. And this kind of tells us we can actually go and see what the new records were in the unchanged records. Great, so we are going to confirm it, and that's the demo. So at any point in this process, you could rerun one of the tools, rerun one of the agents. You have full control over what is going on. Now, back to the slides. So how was this actually implemented? Every agent is an instance of an agent goal workflow. And so the agent will run the LLM in a loop, as I mentioned, the agentic loop, to figure out what tool to call next, what tool arguments to use, or whether it wants to finish the agent. And when that's the case, it'll block the completion signal or the tool execution until it receives a signal from the user. So here I show how you can confirm the tool and it leads a signal. Once it receives that signal, you'll either execute the tool as an activity if that tool is just code, or if it's starting a new agent. So the supervisor agent starts the submission path parser agent, it's going to execute the tool as an agent, and this will start up the new agent. So the supervisor agent will now start a new submission path parser agent goal workflow. Now, the user was talking to the supervisor agent, but now that the submission path parser agent is running, the user needs to talk to the submission path parser agent, the new agent that started. And so in order to kind of swap out which agent the user is talking to, we have this bridge workflow that stores what the current active agent is. And the bridge workflow, one of its primary purposes is to route user human in the loop messages to the active agent. And so that's why the bridge workflow will store this active workflow, child workflow slash agent. Well, the supervisor agent will actually wait for the other agent to complete. And once that agent sends its completion signal, the bridge workflow will swap back in the supervisor agent in place of the submission path parser agent. Okay, the bridge workflow also has another purpose to aggregate all the messages to show on the front end so we can see it. And then the third purpose is it serves as an inner agent data store. So the submission path parser agent, the LLM extract catastrophe data values, has a lot of output. It outputs 59 events. And so that activity will actually query this inner agent data store to save that information. And then the later tools will query the inner agent data store to retrieve the information when it's needed. So for instance, the populate seedent data tool will query the inner agent data store to retrieve the information, the prior information. And so since this data fits under 2 megabytes, we can just store it directly in the workflow. And we don't need an external data store, but if we had a lot of data, we would definitely want to use an external data store. And that's kind of one way we can pass a lot of data between the agents without just putting it all into the LLM context window. Great. So bridge workflow routes to appropriate agent if you want to take two things out of this architecture. And then next, I want to talk about my original design and how I changed it to use multiple agents and human in the loop and why I did that. So originally I had one agent with 4 tools. The submission pack tool ran this fixed workflow, extract as of year, identify sheets, extract the data. And this worked great in a demo setting, but it wasn't adaptable to different types of sheets. It might work on one specific sheet, the fixed workflow, but if you put in a new sheet type, it wouldn't work. And the reason is that actually parsing these submission packs is was quite a difficult task. And so you really want to have some human in the loop to be able to say, hey, no, actually, I want to use this sheet. Hey, when you're extracting the catastrophe data, make sure to use this column and to intervene. So the reason I ended up splitting this workflow into actual agents is to allow it to be dynamic with what the user wants. And that's why ended up coming up with this whole shebangle that resulted. And yeah, so essentially, two important takeaways are think very carefully about where you want human in the loop. Where do you want the human to be able to intervene and say, nope, actually do it this way. Actually, I want to redo this agent. Use human in the loop if you need that functionality. And then the other takeaway is use modular subagents rather than just giving one agent all the tools, splitting it up into smaller agent goals. Hey, I just need to extract this catastrophe data from the submission packs, or hey, I just need to identify the catastrophe sheets, helps to do context management for all of the agents and ensure that they're focused. So it's a very good design pattern. And then my main takeaway from this whole project, it was really fun to build out. And it's cool to see how we can automate and accelerate some of these slow processes so we're not like the sloth in Zootopia stamping the receipts or whatnot. And so there's a lot of it's cool to see what's going to happen with all these AI agents, but we do have to think very carefully about do we trust these AI agents and do we have the proper guardrails and human in the loop to make them actually work and be useful for people? Thank you so much for sticking through and listening to the presentation. You guys can check out the code and an accompanying blog post where I dive into even more of the design decisions. Hope you enjoyed it and have a lovely day.